Hello guys, and welcome back to another episode of chemistry. And of course, today we are going to continue our study on aldehydes and ketones. We're taking them together because they are carbonized. Okay, so now I want to look at the reactions of aldehydes and ketones. Reactions of aldehyde and ketones. Okay, this class promises to be very short. Okay, so within the twinkle of an eye, we are done with this class. But do not forget that this tutorial is brought to you by the O3 School JAMB Practice app. Okay, it is all you need to succeed in your exam. Let us see a question from the application now. This is 2008 question number 47. It says that the reduction of alkanones with lithium aluminum hydride produces A, says primary alkanals, B, says secondary alkanals, C, says tertiary alkanals, D, says polyhydric alkanals. Okay, so you may know the answer, but why is that the answer? Okay, so at the end of the class, after we have learned, after we are done with this reaction that aldehydes and ketones undergo, you'll be well breasted with the reaction that they undergo, and then you know which is the answer. So now please make sure you get the application, download it and activate it. Okay, activation is just for a little fee. All right, the app has all you need to succeed, has all the past questions, lecture notes according to the JAMB syllabus, question search feature, mock exam every Saturday where you get used to JAMB past questions, JAMB likely exam questions. You see your results released every Saturday. So you are competing with every student that is writing JAMB in this particular year. So please do not fail the application. Jump on it and start practicing today. So let's see reactions of aldehydes and ketones. Now, the first reaction we're going to consider is what is oxidation, obviously. Number one, that is what? Oxidation. Okay, so for aldehydes, we have seen through our course of study of aldehydes and ketones, I've talked about oxidation severally, okay? And we know for a fact that aldehydes are oxidized to what now? To carboxylic acids, okay? So there's no two ways about it. So aldehydes are oxidized to what? To carboxylic acid, all right? So please just know that. Okay, so let us just see the reaction. Let us represent the reaction. Let's say we have an aldehyde like this, RC, double to OH. Okay, it's being oxidized. What you're going to have directly is a carboxylic acid. Okay, you are going to have a corresponding carboxylic acid. So I'm going to have CH3. So I'm going to have C double to O, then what? OH. Okay, simple as ABC. So this is what definitely what happened. Or let me just say R. Let me say R. Let me say RC double to OOH, because this is the general formula for the reaction. Okay, so this is the oxidation. When you oxidize an aldehyde or an alkanal, the result you have is what? Is a carboxylic acid. This one is our aldehyde or alkanal, and this is what our what now? Or Egbon is our carboxylic acid. Carboxylic acid. Okay, so if the R group is CH3, let's say now CH3, C double to O, okay, H. That means this is what? Ethanol. Okay, if it is being oxidized, what are we going to have now? I'm going to have our CH3, C double to O, OH. These are what? Our ethanoic acid. Okay, this is our ethanol. Okay, what this is our what? Ethanoic acid. Okay, so that is that for that. So this is the first reaction we're considering. This is for aldehydes, but for ketones. Okay, so if you have a ketone like this, this is for aldehydes. So okay, it's for ketones now. For ketones, okay, so if you have a ketone like this, CH3, C double to O, CH3. Okay, once you perform oxidation on this, nothing happens. Okay, nothing happens. Okay, so that means that ketones resist. They know they agree. Oxidize anything. Oh, so once you oxidize a ketone, they look you for face. So oxidation of what? Alkanones or ketones does not happen. Okay, it does not happen. So it does not exist. So you cannot oxidize what? A ketone. All right, so please take note of that. So you can oxidize an aldehyde to a carboxylic acid, but cannot oxidize a ketone. Okay, so please, that's why we're taking them together. All right, so that is first reaction, oxidation reaction. Then we're just going to quickly look at the second reaction, which is what? Reduction with hydrogen. Reduction with hydrogen. Number two, reduction reduction. Okay, so reduction. When I look at oxidation, let's look at what? Reduction. Okay, so an aldehyde. Now let's look at first of all an aldehyde. All right, so you can reduce what? An aldehyde to what? To a corresponding what? Alcohol. Okay, so if you reduce an aldehyde, I'm going to get what? Corresponding what? Alcohol. Okay, but reduction of what? Reduction of ketones or alkanones, reduction of ketones or alkanol will always give you a secondary alcohol. All right, please take note of that. Okay, reduction of what? Of a ketone will always give you a secondary alcohol. All right, because the reason is because the carbon that is now what bonded to the OH group that is forming the alcohol might now become what? A chiral center. All right, so that will give us what? A secondary what? Alcohol. So that means it must be bonded to at least two, no, not at least, must be bonded to 2 R groups. It must be bonded to 2 R groups. Let us see what I'm talking about. So for aldehyde, let's say we have an aldehyde like this, CH3, C double bonded to O, okay, an aldehyde, so I'm going to have H. Okay, so reduction with what? With hydrogen in the presence of a nickel catalyst. You can use either nickel catalyst, you can use lithium, aluminium what? Hydride. Okay, you can use this, you can use what? Nickel. Okay, they are both was reducing agents. Lithium aluminium, this lithium aluminium hydride, okay, is a very strong reducing agent. It's a very strong reducing what? Agent. Okay, it can almost reduce every carbonyl, every compound having a carbonyl group. It can always reduce it to an alcohol. Okay, so please take note of that. So so this can reduce it to what now? To an alcohol, to the corresponding alcohol. So I'm going to have CH3, C bonded to what? To OH, then H. Okay, so that is that for what? For that. So now for ketones, if you have ketone, for ketone, okay, if you have what? A ketone like this, CH3, C double bonded to what? To O. All right, then I'm going to have what? Our CH3. This is our ketone. Okay, this is our propanone. All right, so if it's being reduced, okay, by hydrogen, means to say in the presence of nickel catalyst or lithium aluminium hydride, okay, I'm going to have what? Our secondary alcohol. That is CH3, COH, okay, then CH3 here. Will be our H. Okay, so now the reason why this carbon here is not a chiral carbon. It's not a chiral carbon, right? That's why I say it might give you what? The new carbon that is now bonded to the OH group will now give us may now become what? A chiral carbon. But we know that for chirality, it must be bonded to what? 4 different groups, okay? But it's bonded to a methyl group here and a methyl group here. So that's why this one is not chiral. But if, let's say, for example, this one is not CH3, but it's C6H5, okay? Or it is what? Let's say C3H7, all right? So definitely this will become what? A chiral what? Carbon, all right? So please take note of what of that. So the only certain thing is that what? It must always give you what? A secondary alkanol. Okay, so reduction of what? Of an alkanone. Reduction of an alkanone. Know this and know, please put it in your head. Reduction of an alkanone will always give you a secondary alkanol. As you can see here, this is the carbon bearing the OH group, this one arrow group, this another arrow group. So 2 arrow group directly bonded to the carbon bearing the OH group. So it's what? It's a secondary alkanol. So it's secondary what? Alkanol. It must always give you a secondary alkanol. All right. So please, so why for this? It definitely will not give you a secondary alkanol. All right. So please take note of that. So now, these are the 2 reactions we're going to consider. Now, we'll just go to the application and take some questions, and we're done. The next episode, we're going to discuss the test for what? For aldehydes and ketones. Okay, how can we distinguish between them? Okay, so just stay put and stay with us. Now, 2008, number 47, which we're looking at area, said the reduction of alkanones with lithium aluminum hydride produces what? Definitely is a secondary alkanol. All right, so please take note of that. All right, so there are many other questions on the application. Just make sure you just do your thing, download the application, and what? Start practicing, start reading, studying. Okay, even if it's 1 week to the exam, you can do it. Just try with this application. You can do it even with 1 week to the exam. You can have a very good score. Look at our testimonies and be amazed. All right, so in the next class, we're going to look at the test. Okay, or how we can distinguish between aldehydes and ketone. My name is Pastor T. I will see you there.